Okay, so let's look at some problems here. Which value of R indicates a stronger correlation? R equals 0.769 or R equals negative 0.934. Remember, the strength of a correlation does not depend on whether it's positive or negative, but on the absolute value of the number. So the bigger the absolute value of the number, the bigger the number is without the minus or plus sign, indicates the stronger correlation. So in this case, the absolute value of this R being 0.934 is bigger than the absolute value of 0.769. So the negative 0.934 represents a stronger correlation because its absolute value is bigger than the other one. All right. Discuss the difference between R and rho. So R represents the sample correlation coefficient, while rho represents the population correlation coefficient. Okay, so we're trying to use R to give us information about rho. You know, just like we were using X bar to try and give us information about mu, the sample thing giving us information about the population item. What does it mean to say correlation does not imply causation? The fact that two variables are strongly correlated does not in itself imply a cause and effect relationship between the variables. All right, so let's look at this. So on the following page, we actually have a table that shows the ages of 11 children and the number of words in their vocabulary. Okay, so there's the ages and the vocabulary size. And what we're going to do is trying to see if we can establish some sort of linear correlation between these. All right, so first we're going to see which is the correct plot. Now, in order to do this, we would really just try and find out, which one has 1, 6, 2, 230, etc. So 1, 6, that's not right. There's 1, and that's probably about 6 because we probably can't see the difference in there. This doesn't have 1, 6. This doesn't have 1, 6. So just from that first point, I actually know that it must be this one. So I'm just trying to see what would actually happen if I plotted those points out. So again, here we're not actually doing the calculation, so I'm going to say that R is 0.980. So what does this tell us? Well, there's two things again. Is it positive or negative? And what is the strength? So it's a positive correlation, and being close to 1, it is strong. So this would be a strong positive linear correlation. What would that mean? Well, again, this is ages versus vocabulary size. As age increases, the number in the words in the children's vocabulary tends to increase. The positive correlation showing that the increase in the number of words, the increase in the age and the increase in the words in the child's vocabulary go together. All right, so now we're going to test to see if it's significant. So we already have our R of 0.980. So let's keep that. Let's remind ourselves of that. R equals 0.980. So we need something to compare it to. So if we're going to do 1%, and remember we were doing 11 pairs here. So I'm going to jump ahead here to the table. So here's 11 pairs. We were doing 0.01. So that would give me a critical value of 0.735. So I can easily, the critical value is 0.735. I have 0.980, and in absolute value, 0.980 is greater than 0.735. So there is sufficient evidence at the 1% level of significance to conclude that, as we've seen, a strong positive linear, there's a strong positive correlation between children's ages and the number of words in their vocabulary. In other words, I really should have said there is a significant linear correlation. Let me replace that. That there is a significant linear correlation. And what we saw was that that correlation is positive. The significance doesn't tell you how it's correlated. We're saying that the strength of that correlation is significant. So it was significant, and it's a positive correlation. Let's take a look at another one. So the data on the chart below this is of 8 high school girls and the height of 8 high school girls and their scores on an IQ test. So here are the 8 girls' heights and that girl's score on an IQ test. Are they correlated? Well, if we were to plot these out, again here, we would just look for 61, 106, 61, 106 seems like it could be that point, a point in there. Oh, this is even in the wrong range here there, as is this one, so it's got to be A or C. And well, one interesting point is we could see which one, say, has this point. So this is 52, 56, 120 something. So 56, 127 is there, and it's not represented here, so it has to be this one here. Okay. So there is our scatter plot. If we calculated the R value, negative 0.027, that, although it's negative, that's very close to 0. So we would really say there is no linear correlation, meaning there does not appear to be a linear relationship between the girls' heights and the IQ scores. And we could test that, although I have a feeling of what we're going to see, but we could use, remember we have the R of negative 0.027, and we have that there were 8 pairs of data. And so if I go and look on the chart, 8, and for 1% significance, 0.834. So we'd be asking, is the absolute value of negative 0.027 greater than 0.834? No. So there is not sufficient evidence at the 1% level of significance to conclude that there is a significant linear correlation. So The data does not seem to indicate that there is a linear correlation between the girls' heights and their IQ scores, and again, not surprising of a result.